Hey everyone, welcome back to the lab. In this video, we're going to be talking about how to build simple interactive islands with F# and HTMX. So for those that don't know, HTMX is a tiny JavaScript library that gives your HTML superpowers, allowing it to act more like a modern interactive app than a crufty old enterprise page. It does this by allowing you to swap out only bits of a page rather than requiring a full reload to change the UI. And this is what gives those old HTML pages that cruftiness. It's like you click the next page or something like that and the whole thing flashes and then everything reloads and it takes a long time. And so what these client-side frameworks are doing that, we've all started using, you've got your Svelte, your React, your Vue, and now you've got these kind of more full stack things like SvelteKit or Next.js or Vue.js. The only thing that they're actually doing to make them not do the full flash is that they're trying to figure out the part of the page that they want to change, and they're only changing that. So essentially, the only thing you need to do to get the same experience, user experience that those huge frameworks provide is just make sure that you're not reloading the whole page. So keep that in mind as we go through this. So this essentially means that you can build modern apps without any client-side framework, just you and your server-side rendered HTML or X, because it allows you to do that thing where it just only renders or re-renders the part of the page that's changed. So that's what HTMX allows. So I've recently been doing a lot of server-side HTML rendering with F#. In fact, that's what's currently running this site that I'm reading this on. In this post, we'll explore how to integrate HTMX into F# Giraffe's server-side rendered pages to give them superpowers and make them feel more modern without the use of all these huge, honestly, in my opinion, crufty frameworks just to build some simple UIs. Okay, and so the question we're trying to solve is how can you integrate HTMX with F# Giraffe's server-side rendered HTML pages? And here's my answer. So in this post, we'll be building a simple example app that utilizes HTMX for pagination. The paradigm we'll be using is interactive islands, which allows us to sprinkle extra interactivity where it's necessary without it invading our entire application. This is a similar approach to Astro, which is another mainstream common JavaScript framework. And I think this idea works really well for actually all kinds of web pages, which is why we're using it here. Okay, and so here's a little diagram trying to show you what I'm talking about with HTMX interactive islands. And so when you come to the page the first time, we're going to be using a normal GET request, right? That's just what the web uses. We have to handle these things. And so on this normal GET request, we're going to have to do a full page load, which, loads all the headers and the scripts and stuff, and then actually loads the page content. And of course, hopefully you're caching parts of the assets that aren't changing, but we need that full page load. But where, old HTML would go is you have an ahref and you'd click the next or previous button. It feels old because what it's doing is it's going to a new URL and it has to reload the entire page. So basically every time you're doing the next previous or whatever your thing is that changes the URL, you're doing this full page load. Now what HTMX is allowing us to do is basically say, hey, there's actually this little island that is on the page that we want to change. But when we change this part, we don't want to change anything else. And so we can then send this request to the server and we can basically do a partial load. And so this is in React, you're going to change a piece of data and it's going to go to the virtual DOM to figure out what parts of the components rely on that piece of data and the DOM tree. And then it's going to change that. This is how we're doing that just at this level using just normal-ish requests like you'd expect in kind of a web environment. And so for our purposes, we're going to be doing our pagination of this big list that we're building. I'm using hxgit to show you just how simple it is to swap out these little islands of interactivity that we want without having to change up our whole simple HTML rendering that we've already been doing. So that's the idea. So the example app is going to do this. So, on page load, as I talked about, it's doing the full normal HTML load. What we're going to be doing is creating several random pieces of data just to kind of have something to render on the page. So you can see that this is actually doing something. And then it's going to save this to our database. And then what we're going to do is we're going to look at the database and grab the paginated data based on the URL. And then again, the pagination is actually going to be controlled by HTMX. And so when you click the next or previous buttons, we're going to be making this HTMX request here. And then we're going to have headers and stuff on it that allows it to know oh, I want to update this interactive island with the new data that was returned. And so together, this is going to provide us a simple overview of how you can mix your normal HTML loads with interactive islands powered by HTMX. which I think is a pretty powerful combination here. All right, and so to kind of demonstrate this and to prove this like actually works, I'm going to be building an example app. And so this is what the app has. Basically on the back end, and this is like similar to how I build most of my apps. This is basically Cloud Seed. Where on the back end, we're doing all F# here. So we're running F# Giraffe. We've got Entity Framework, Core, and DB up to actually do our data, which is just to save and read out the paginated data from our database. And then we're going to be sending over our HTML, which is just server-side rendered here. And then our interactive islands are going to be powered by HTMX. So that's it. We are not going to go into detail into a lot of these things, really just trying to focus on HTML and HTMX in this. So if you're interested in those or learning more or you have questions, you can check out the draft guide here, the HTML guide here, and then my Entity Framework guide here. And then if you want to learn more about like containers and Docker Compose, that's kind of how I run all my projects. You can check that out here. So I'm going to be sharing some source code. I'm going to be walking through like a demo in this video. But if you want the full project code to just download it, run it yourself, you can get it in my example project repo, which is available to Himinian subscribers. And so I have links to all of that below. All right, so the first thing we got to do is install HTMX. This is really simple as it's just a tiny JavaScript package served via CDN, so we can simply include it in a script tag at the top of our page. And you'll notice this a lot when you're working with HTMX, is we're kind of trying to move away from like these really crufty big build pipelines that you kind of need with like React and SvelteKit and all this stuff, because it's not really HTML. Like it's not really the thing that it actually needs to end up rendering in the browser. And so we're often trying to go back to like these older technologies that are just simpler. And we see that here with it's just a CDN package and it just kind of works. Obviously you can like vendor this and you might want to vendor this in production, but we won't go into that here. And so once you have that on your page, you're good to go. We got HTMX, so you can start using this stuff. Okay, so what are we actually going to be building? Basically, it's this. Because this is a video, I'm going to show you kind of the demo project to prove that it's like actually working. So we'll walk through some of this code later, but for now, I'm just going to kill my Docker containers and restart them. All right, so you can see my F# HTMX example project is running here. It's listening. And here I've got it set up at localhost 5001. So let me remove the page attribute so we can kind of go to the main page. And we can see that we've loaded like 5 random pieces of data here. And I'm just gonna do this. And now we've got a next page. And if I click next, now we've got more data. And so we can kind of paginate this way. And what we can see is that like, this is pretty fast. And obviously I'm running on localhost, so it's gonna be fast. But there's no flash. You see how there's no flash? And that's because we're using this interactive island. We're not doing a full page reload. We're only changing out the part that needs to change for this. And this is going to be this whole section here, including these buttons, which we would consider our hypermedia controls. And now just to prove this, I'm also just going to open up the network tab here, and I'm going to go back to our main page here. And we'll see that, Sentinel's document is loading. We got a few other things. These are just like extensions. And this is like 3 kilobytes. And now if I am clicking next, we can see that I'm sending this guy here via HTMX. And all we're doing is reloading this little section. And obviously we're not saving much. This is like a very simple page. We're only saving like, 300 kilobytes. The reason this feels so fast is because actually the browser has to do a lot of reloading when you reload heads, things like that, because it has to assume that everything's changed. But here, because we've only told it that this area changes, these actually move very fast, and it, basically feels like a client-side framework. It feels like we're not doing anything crazy. Okay, so that's what we're building. Now let's go actually show you how to do this. So this is rendering interactive targets, which should really be rendering interactive islands with HTMX. Okay, so now that we have HTMX available, let's build up our little HTML table. The way I'm thinking of HTML&X targets is interactive islands. We can think of each of these islands as a unit of interactivity that's semi-self-contained. HTMX calls this a target, and this seems similar to me to what we might call a component in mainstream client-side frameworks. The main difference I see between targets and islands and typical client-side components is that a target island is typically a larger self-contained component that itself may contain many subcomponents underneath it. This is because there's a bit of overhead involved with target and island creation. And so some examples of this are like, a button is probably too small to be a target or island because we wouldn't necessarily want to like have every button have its own target because there's going to be like several on the page and like it's not really self-contained. It's not really doing much for us. But a page or a section or maybe a widget is a better word for this is like probably a better granularity because we can get a good amount of interactivity with like a single request. So, you know, we might have multiple sections on the page, those little islands, and then internally they might have all sorts of like buttons to control them or UI elements or content or something like that. So I really think of these as like a section or a widget is like probably a good granularity of this. And we don't want to go down to the component level though. So that's kind of how I'm thinking about it. But note that I am still playing around with this stuff. So this might change in the future as we go, but I think this is definitely a really good starting point at least. Okay, so for our simple example page, we really only have two targets or two islands that we're trying to render. The first is the main page. And now this is the full page render, what you'd expect on a normal request. And while it's not technically a target or island itself, I do like to be explicit and complete, if you will, and handle all cases. So I'm handling the default here. And this is a little foreshadowing that we're going to be using some of these F# type features where we can basically have match statements, and we want the match statements to be complete or it's going to yell at us, which is good because we don't want to have unhandled cases. And this is why I want to be complete and say like the main page is a thing that we might want to render. The next one is the sentinel table. And so this is really the only island we have here. And this is the data that we're going to be rendering. And so it's including the data table along with the buttons that control it. And so these are the hypermedia controls that are together with the actual hypermedia content. And this is how we're getting this idea of a self-contained interactive island that's both displaying its content, but it's also controlling how we can update it. And I think this is going to be pretty critical, I think, in most applications, because just kind of like the locality of behavior or the idea of we want these things to be easy to manage and not have state everywhere. I think we're going to want these kinds of ideas of these coarse components, these widgets, if you will. Okay. Target parsing from request. So how do we know what target the page is trying to get from us? So let's say we have multiple islands on the page. How are we going to know that like, oh, it wants us to render an island versus it wants us to render the whole page? And we want to get this right because if we, send down the wrong HTML and HTMX tries to like insert it there, we could have this like endless nested page on page on page, which might be a fun like project, but like obviously not very useful in an app. So we need to know, like, based on this request, what do you actually want us to re-render? The best way I've found to do this is to rely on the headers HTMX attaches to requests it sends. So the first is HX request, which is just an easy way to say, like, is this an HTMX request or is this like a normal request? Like from the browser. Like the browser, it can't send HTMX requests. It's just going to send you like a plain old, GET or whatever that is. The next is HX target. And so this will be set with, if you have a target in the HX target attribute, what is that thing? And so this is set in the header, which is actually really helpful for things like this. So by utilizing these headers, we can uniquely identify what the page is trying to re-render and route that to the target we have registered for it. In F# Draft, we can use a simple helper function I built to parse this from the request. So this helper is going to do checking both the HX request and HX target's header, and then it's going to try to convert the string into an enum, which we will use later to route the correct component with type safety. And so this is how we're getting, we're leveraging F#'s type system to be able to make sure that we are matching on all cases, that we're handling all cases. But we need to get it into, a format where we can actually check that. So I'm not going to go too much into like how F# Draft works. So if you want to know more about routing and payloads and context and stuff like that, you can check out this post, and then more on just endpoint routing here. So here's the code, which I'll just show you also in VS Code so we can get some syntax highlighting. So here we are back in my project. And basically we just have this function get target from context, and we're taking in a strenum, which I'm going to talk about later, but this is basically how we're just doing an enum backed by strings. And you can imagine that this prime A is the actual enum that we're talking about. It's going to take in the context, which is how Draft is passing around data, so we can like see if there's headers in this case, but you could also imagine like parameters. And then what we're going to return is a prime A option. So this is the enum option. So if it exists, we'll give the sum. If not, it's just going to be none. And so here we are. I'm just checking HX request. If it's not HX request, then we know that this must have no target. So we're just returning that. But if there is an HX request, then we're going to try to see if there's an HX target. Now note that there might not be a target, right? Like you can do HTMX requests and it just might not be a target. So we are going to return a none if there's nothing. But if we try to get this and we see that it's a sum, then we're going to bind this with our target strenum again here, get enum. So we're going to try to basically parse it from our string into the fully type safe enum we have here. And and this returns an option. So if we try to parse it, but we don't know what that thing is, it's not going to throw, it's just going to return, hey, we didn't find anything. But we'll talk about the string num later, because I do think it's really important for allowing this to be type safe. Okay, so that's how we get the target from the request, so we can know what target the page wants to render. Now we have to actually use this to selectively render that part of the page. So do you want us to give you the full page? Do you want us to give you just the table? This is how we do it. So this is going to be our page entry point, which will handle full and target re-renders. Note that I'm using the same entry point to render the page and all its subtargets. This is in keeping with the idea of interactive islands, where we are really building a simple page that just happens to support partial re-renders of its islands. And I'll note that this is also a way that we can kind of start sprinkling in interactive islands where we want, but there might be widgets on the page that we don't want to be re-rendering, and so we don't have to do any overhead or setup for this. So we only really have to do this for the ones that we want to be re-rendering like this. And so this may look a little weird at first, but I think this leads to much simpler state and view management overall. When we think of reactive or functional views, it really doesn't get much more functional than rendering conditionally based on past end parameters from the URL, using the URL as a state of, or as the source of truth for state. And so you can imagine like the way that the default web works is you go to a URL, and then that's going to hit the server, and the server is going to take the parameters off, it's going to look at the routes, and it's going to like try to re-render something. So if we were to maybe not do this, and we're going to have like a new URL per widget or something on the page, the problem is that it is possible for a browser to try to go to that thing with a normal request, like that's not an HX request, and it will render like just the table maybe, but it's like, doesn't really make sense because it's supposed to be in the page. And so the way that I found to kind of manage this is to be like, look, this page has a URL, and then we're going to have a capability for you to render parts of the page, but we're not making this a full page. That's like browsable by the browser, because that wouldn't make sense. And this also allows us to say like, if any of our subcomponents needs more data, that data should be in the URL, because this is how we get deterministic page loads. Like we expect the URL for the most part to be if we were to copy and then paste that in like a few minutes or in another tab, it should give us the same thing. And I think this is a really great part of the web that honestly a lot of these newer client-side frameworks break, because they kind of have to deal with state directly, and they don't do a very good job of it. And this is how we can, I think, manage this much easier and kind of be in keeping with some of the good parts of the web. Okay, so enough ranting about that. Let's see how it actually works. So basically in this page, what we're trying to do is take in some props, like the target we're trying to render, and that we kind of got earlier, but we're also going to do things like what page are we on, what's the page size if we want to allow that to be dynamic, stuff like that. We're going to create the sample data, again, just so we have something to render on the page, because if it's just an empty table, not useful. We're going to go fetch the paginated results from our database. We're going to render the Sentinel table component, which I'm going to show next, but we will kind of show how this like turns into HTML here. And then we're also going to create the full HTML page document. And then crucially, after doing all this like, cruddy stuff, we're going to be using that enum that we created earlier based on the target to actually do our type safe selective rendering of the interactive island that you're looking for based on the requests. Okay, and so let's look at some of this code. So I've got main page props here, and you can imagine that this was basically filled in with that function I used earlier in our draft handler. Not going to go too much into that, but you can imagine we use that function. And then we can see that we got the page thing. You can imagine this was filled in with our page parameter. And then we just have Sentinel count here, which allows you to basically set the page size. And here's our entry point. So we've got render main page async, and this is, again, that how I'm saying, like, I think there should be one entry point per URL, and then we're kind of using the props that we have to, deterministically re-render based on the data we have in the URL. And so we're using servers tree, which is just how I do dependency injection. We're passing in those props I just showed you. And then we are creating all of the random data that I talked about earlier. Then we're fetching the paginated data from the database, throwing if we don't get data that we want. And then here we're rendering the Sentinel table component, which I'll talk about in a second, but just imagine this returns that, table HTML. But crucially, that this is the table interactive island. This is the self-contained interactive island right here. And so now let's look at what the full page is. And so here we just have, the standard, this is an HTML document. We've got our headers. This is where we're adding HTMX. And then we're just saying, here's our header that we saw earlier. And then we're rendering this self-contained table right here. And so it's crucial to note that this table that's on the main page is the same exact thing that we pulled out here. That's the same interactive island. And it's important because now we can kind of look at how are we deciding what to return? And again, we're using our props.target, which was filled in with that function I showed you earlier, which was converting from the headers to the enum. And now we have a match statement, and we're saying, hey, if it's the Sentinel table, we're just going to return this interactive island. If it's the full page, then we're going to return this full template that we built that includes the interactive island. And because we're using a match statement with F# over a type safe, discriminated union, if you will, an enum in this case, now if we were to change the targets that are allowed on this page, we would now get a build time error telling us that, hey, you didn't handle all of the cases. And so this is the beauty of type safety, because now we're turning this error that would be a runtime error, which often means you're going to hit it in prod, into a build time error by relying on the type system. So now on to rendering the data table. So that's how we're routing from the HTMX request to the target we want. Now we are going to dive into rendering the HTML, which actually has the HTMX controls embedded in it and sends those requests. And because it's both the component and it includes its own hypermedia controls, this is how we're turning it into an interactive island where it's self-contained. So here we have a few things. So we've got a render Sentinel table pagination, and this is going to be rendering the buttons, which serve as our hypermedia controls. And then we'll talk about quickly what the HTMX things are as we dive into the code. And then we have the render Sentinel table component, which kind of puts all this stuff together. Okay, so let's start with render Sentinel table component. It just has props. The props are, does it have a next button or next page? What page number is it on? And then just a list of sentinels that it's supposed to render. And this is what was called in our main HTML page. So first we're just building up the sentinel rows. There's just a for each to get a row per sentinel we want to render. And then here we're saying, hey, give us the ID that goes to this type safe enum. And this is how we're saying, hey, we can uniquely identify this interactive island, and we're being as type safe as we can be. Obviously, we're turning this into a string, but we're at least relying on that main type and the source of truth to make sure that we're using the same string everywhere. Here we're just creating our simple table and passing in the rows. And then all we're doing here is putting the page number and rendering the pagination. The pagination is just out in its own component because honestly, this like string formatting stuff gets a little bit complicated with stuff everywhere. So it's just easier to have it in its own component. And so here we're just returning previous button, next button, and this is pretty straightforward. So for the previous button, we're saying if we're not the 0th page, then we want to have a previous button because there's a previous page to go to. HXGet is just sentinels, which is like our page's root, if you will. And we're just passing in this. And so this is kind of, again, why I think it's important to, or simpler to just have one URL and one handler per page, and then you dynamically, based on the parameters, figure out what things you want to re-render. Because otherwise you could imagine that the URL management just gets crazy because there's so many URLs you have to keep track of. Here it's just one, and all we got to do is say, hey, what is this page supposed to do? What does this hypermedia control do? And so this is just saying, hey, give us the previous page, and then here we're using HX target using the ID that we got from our helper here, which basically is saying, hey, when you go fetch the HTML there, replace this target with that. And we saw that this was on our interactive island of the table. And so we're just going to swap out that table with the new table we get returned. The last thing here is HX push URL, which is just saying that we want this in history. And so we are doing a background AJAX call. And so we don't get the standard history you'd get with like a normal browser get. But this is how we can basically get that. And it's very easy. We're not accessing the history API or anything, although that's what's happening under the hood. All we got to do is a true if we want it and just leave it blank if we don't care about it. Same thing for next. The only difference is, here we're doing page +1 instead of -1. Okay, we kind of glanced over the raw string HTML, but if you want a deeper dive into that, you can check out this video, which goes a lot more into that and kind of the intricacies and gotchas and stuff like that. All right, type safe targets with F# and HTMX. Okay, so at this point, we've walked through how to get HTMX on your page, rendering our HTML pages with embedded HTMX controls, and routing to the correct target based on HTMX headers. In this section, I want to dive into how we're actually accomplishing type-safe targets with strings and enums, because this is a bit of a faff to set up, but I think it is very important to leverage the full power of the F# type system. The reason this was hard is because F# does not natively support string enums, something like the strenum and Python. This is not that surprising as C# does not do that either, but it is a bit of a pain. And so the way that you usually get around this in like C# is basically by just like having a static class that has a bunch of static members that are strings, and that's how you're kind of doing strenums. But the problem with that is that like we want to be able to enumerate these things, and ideally without too much reflection. And F# allows us to, when we have a discriminated union, to have these kind of match cases similar to Rust, where you can basically be type safe knowing that you've handled all cases. We can't do that with just static members unless we're doing some weird reflection. And so that's why enums, if they were backed by strings, would be really helpful here, because we can just use strings, and we can also make sure that we're handling all cases. The reason that this is a pain for us and why I'm really focusing on doing that is that HTMX and HTML themselves are not very type safe. Like, if we think about it, they're really just like big strings. And like, yeah, you can have your linter somewhere, or you can have like, your JSX or something, but that, requires build time. But if we're just kind of building up this stuff, it's just like mostly throw a string in there and then we'll call it HTML. But it's absolutely critical to get these target IDs and URLs correct. Otherwise, your whole page fails. Like, everything can work, but if you get the URL off by one, or you don't have the parameter, or using the wrong target ID, or like anything like that, it's not going to work as you expected. So this means most of these errors will be runtime errors, and thus relatively hard to catch unless you have tests covering them, but we know that you won't. So you're going to find this in prod, which, it's just not great for anybody. So we want to try and move at least some of the most important parts of HTMX into type safe land so we can get build time errors instead of runtime errors. So for this, I wanted to create a string enum that allows for easy parsing between string and enum, so we can move from request data into type safe code representation. So pulling those headers, do we know what this thing is? If we know what this thing is, let me make it a type so that we can actually use that for targeting in a type safe manner. And then enum to string, so that, when we're trying to actually build up our interactive islands, we know that we're using the string that actually is associated with the enum. So again, we're not breaking our page on accident, or at least we're doing as much as we can to not break our page when we're converting over to strings. So this is how I did it. Basically, I created a string enum, and what it does is it takes in an enum and a map of enum to string, and then it provides easy access to helpers. And the helpers are here, which is just get string, which takes in an enum and returns a string. And we know that this must exist because we have type safety here. But here it's going to say get enum, and it takes in a string, and it's going to return an enum option because we have no type safety, so we don't actually know if it exists or not. And so I have this in code here. I'm just going to honestly not even go over it on camera because it's going to take a while and it's just going to confuse a lot of people, but I am going to just like slowly go through here. So if you're interested in seeing how this works, you can, pause the video and look at this. Basically, takes in an enum to string map. We get all the cases of this enum. We're going to save this off as an enum name to string lookup, which allows for fast lookups. We are going to do the opposite, which just takes the string so that we can go to enum lookup very fast. So now I've got it both ways. And then that's how we're just using, get enum, string to enum option. If we don't have it, we're just returning a none. And then a get string. And because we're type safe here, we can just return a string. So if you're interested in diving more, I've got the code on the site. You can pause the video here, but that's probably as much as we'll go into for now. What I will show you a little bit more is how we're actually using these. So, I have my main page targets here. We're using enums. It can't be a string enum, so we just have to back it with ints. And then I'm creating the string num here. So I'm saying, here's the enum that we want, main page targets. This is how we're getting the type safety. And then we're saying, hey, we have a function of enum to string, and then we're going to say, for each enum we're doing this, and then this guy is going to give us all those helpers so that we can go both enum to string and string to enum. And that's basically all we're using it for. And then to come full circle, basically we're using that string num we created here as the target string num. And so this is how we're saying, hey, if we are an HX request and you have an HX target, then I'm going to try to find an enum that I know about based on that string. And if we find it, then we get that type safe enum back. And if we don't, then it's just a none. So hopefully this helps you if you're looking to build type safe targets as well. Sorry if I overcomplicated this, but I really like type safety. So for most people, this probably doesn't matter. Let me know if you have been personally victimized by F# lack of string enum support yourself, or have suggestions for making this easier. I think I'm going to make some posts and see if we can get string enums into F# because I feel like that's a pretty common thing you want. And I just love to find a better solution than this. I don't want to have to build my own string enums. That feels like it should be in the standard library. That's it. A little server-side rendered HTML page empowered by HTMX and built with F#. Let me know if you have any questions or if you have suggestions for doing this easier and better. I'm still learning and playing around with this stuff, so I'm sure there's a lot of ways to improve to make this better, faster, easier to manage, stuff like that. If you like this post, you might also like learning a bit more about HTML DSLs with Draft.ViewEngine. You might also just like to see rendering benchmarks. I tried out Draft.ViewEngine, I tried raw strings, I tried templates with Scribon, and like handlebars, stuff like that. And then if you're interested in kind of the more data side of things, you can check out this post for more on F# and Entity Framework. Finally, if you're looking to build your own apps with F#, you might consider starting with Cloud Seed, which is my F# project boilerplate, and now basically runs on this stack I showed you today. So that's it for this video. Thanks for watching, and I'll see you in the next one.